Hi everyone. In this video, we are going to be setting up Atlas Vector Search locally within our computer using Docker. Now, Atlas is a you can say fully managed service by MongoDB, and they do provide so they do have a separate image called Mongo, which you can pull to create a MongoDB cluster within your single machine. Although it's not fair to say that you will be creating a cluster on your single machine, but going with the terminology that they use, you can create a cluster within your computer using the Docker. Now, uh, Atlas is their separate service, which is also known as fully managed service, with which you can basically go to the website that I am currently at. You can log in, you can create clusters, you can scale them up and down horizontally, also based on your needs. Okay. And they also provide various connectivity and SDKs that you can explore. But what I'm trying to do in this video is I'm trying to show you their Atlas local offering. Although it's not going to be, I guess, for commercial use, but just to showcase how their vector search capability looks like within the local setup, we can do that because it is often good to experiment with something on your single machine before you can consider the decision of purchasing their commercial subscription. Okay. Now, to do that, let me do one thing. Let me open a terminal, and also you would like to spin up your Docker daemon, because needs to be wake up. Okay. So this is my Docker dashboard, and currently there are no images related to MongoDB Atlas, so we will be pulling that up really quickly. Now here in this video, unlike my other videos where I use Python SDK to interact with running instance of any service that I'm exploring, I won't be using that. I will be using their Mongo shell that is there, that comes with the Docker image that we will be pulling. But if you have Mongo shell installed, you can connect with that also, because we will be exposing the port from the container to the host machine. Okay. So first thing first, let's first of all, I would like to do one thing. I would like to write down steps. So let me create a new text file, and I would like to create oh my god, okay, I would like to write down the steps that we will be following in this video to set up this vector search. Okay. So step one will be to simply pull the image. Okay. And then second will be run the image. Now in the pulling, we need to know which image we are trying to target. So the image that we want to pull is called MongoDB Atlas. Now they are calling it as Atlas Local. Okay. Because it is you can say counterintuitive, because Atlas is a their managed service, but we are trying to run Atlas on our own. So that is why they are calling as Atlas Local. Although people love Atlas for their self managing capability, not that you have to manage it yourself. Okay. So after that, after pulling the Atlas local, we need to run it. And specifically, we would be running it on port, because in container, Atlas exposes, as you might be aware from coming from MongoDB, it exposes this particular port. Okay. And after running this, we need a mechanism to basically connect with it. Now, the URL to connect with it will be MongoDB localhost 27017. Now you can either connect with this instance of Mongo using your local Mongo shell that you have, and if you are not familiar, Mongo shell is known as Mongo sh. Okay, you can connect with it, or you can start a Mongo shell from within the container. So this is one of the other ways by which you can connect with the running instance of Mongo Atlas Local. Okay, so now next we are going to set up the vector search. Now how are we going to do that? This step itself is going to be involved. So first step would be, we need to have a database and a collection, right? Now you should be familiar with these concepts before actually. I think I should have pointed out it in earlier, like earlier only, but you should be familiar with these concepts. Okay, so we need to basically create, although when you are using MongoDB, the moment you use a database, it will automatically create it. Okay, so DB and collection. Then we need to think about some data. So we have to insert, we have to call this command called insert many, to kind of insert some documents, because documents is the term used by MongoDB or other NoSQL databases to refer to the kind of data that they deal with. Insert some documents into the collection. Okay, all right. Thirdly, we need to create a vector search index. Vector search index on the we need to create the vector search index on the collection that we just created. Okay, and then after creating the index, we need to finally query it. Now I could just go ahead and go inside the chat GPT and make it write all the commands that uh, we need to basically write. But personally I believe that if you really want to look inside how let's say, for example, while creating the vector search index, it's a involved command. Okay, it is involved of a array of JSONs, and inside the JSONs you have to think about which keys to provide where. If you if you want, you can take that command from ChatGPT or Gemini and copy it here. That can get your job done pretty easily, but I won't be doing that, and I won't be using any um, code fillers also. Okay, I hope it makes sense. So let's do one thing. Let's pull the image first. So I'll say docker pull, and the image that I want to pull is, let me grab it from here only. Okay, so it says it wants me to allow this. So let's allow this, and it will start pulling the image. It would take some time because the image is quite heavy one. It's about 2 GB. So let's wait for some time and then I'll return back. Okay, so as you can see, our Atlas local MongoDB has been pulled. Now we would like to run it. Okay, so to run this, I can run a image, and I can also name the running container. So I will name it as Atlas local, and after naming it, I will specify the name of the image that I just pulled. Okay, but I think before this, you can also print all the images that are there on my system. So I can see I've got this MongoDB local. Now after this, I can do docker run, and then I can specify the name, and I can also specify the port. Let's first specify the port. Which port I want to run this container on? 27017 27017. This is that I want to expose the host machine's port to the port inside the container. Now after this, I can specify the name of my running container, Atlas Local, and after this I'll paste the image name. So if I hit enter, you see all these processes are running, so it will run. Or I could have run it in background also if you prefer that, by specifying the detached mode. Okay, but let's keep it running and open a new terminal. So I just opened a new terminal by pressing Command T. Now I am inside a new terminal. Now what can I do? I can do I can do bunch of things. I can either, if you have Mongo shell on your Mac or on your Windows, you can just enter this and connect with the running instance of your Mongo. But I will just run the MongoDB from the container. Okay, how can I do that? So I'll say docker execute exec in interactive mode, because I want I want I want to basically keep interacting with the shell that will be available. Okay, so docker exec it Atlas Local. Now here I am specifying the name of the container that I want to execute my command into. Okay, so all these steps are prerequisite, and now I want to specify the actual command that I want to run inside it. So which command I want to run? I want to run the command mongo s. So sh, sorry, mongo sh. So I want to run this particular command inside the running container. So if I hit enter, you see this. Now we are inside the Mongo DB shell. Okay, so from this shell we can do all sorts of things that you would otherwise be doing in your mongosh sh local. Okay, so after this is executed, the first thing that usually database administrators do is they use a database. Okay, so I would not be having any database right now. I can probably see also. Let's look at or maybe let's start by running the database first. So I'll create a database. So which database I would like to have? Let's say I would like to create a database uh, called, maybe, I don't know, items. Okay, okay. So it says switch to database items. Now this items will have many collections. Now the moment I specify uh, items, one second, the moment I specify db, if it will refer to the items. Okay, now inside the items db, what I can do is I can so the moment I use the db term, it will refer to items database. Now inside it I can create collection. So maybe I can create a collection for products. Okay, so items dot products we see. Now inside here, what I can do is I can do something like insert many. Okay, you see this command. So let me first of all, I think it would be better to just delete these. Okay, I think it would be better now. So inside the insert many, I can specify an array of you can say JSON like documents. So I'll start creating first JSON. Inside here I need to specify a id parameter. Now id, let's start with 1. Let's also have a name, and inside name maybe I can, for now, I will say in the product I will say flower. For now, very simple. Okay, flower. And I will also specify a parameter for embedding. Okay, inside embedding I will have a array of numbers. So let's keep it simple and let's specify three random numbers. Okay, so now this is my first document. Let's quickly create another document with id2, name, maybe, I don't know, animal. I don't know, I'm keeping it very simple. Embedding, and inside this embedding I'll have 1 2 3, and let's create one more id, and here I will specify maybe name is I don't know, stool, I don't know, just random junk I am specifying. So embedding, and here 0 0.3, 0 0.9, 0 0.2. Okay, and after closing out this, I need to also close my command. So if I hit enter, you see acknowledge true inserted IDs. So these IDs have been inserted. That is being acknowledged by the mongosh. Okay, all right. What is the next thing? Next thing is I want to basically create a index. Okay, because this is my next step. After inserting, I want to create a vector search index on the collection. Okay, so how can I do that? So I'll say db dot um, run command. So this is the command that I want to run. Now this run command will be, now this will be a very involved process. So I want to run it manually, because I don't want you to skip, because at later stages when you will be integrating this into your larger pipelines, what will happen is you will not be able to understand these commands in a much more sophisticated fashion. So I want to run this command. Now this command is going to be basically you can say a JSON. Okay, one second, I think I messed it up. Let me do one thing. Let me run command from here. Okay, so after this I want to specify three keys here. First is create search indexes. Okay, so this is my first command. Now this particular command will have a value, obviously. Now what sort of value it will have? It will have uh, some top level fields. Okay, what is the command that I want to basically run here? Okay, then let's provide vector search for now. Okay, okay, after create search indexes, I want to specify the indexes list. Okay, so indexes list will be, you can say, list of JSONs. Okay, and inside this JSON I will have name of the index. What is the name of my index? Then I will have type of my index. Okay, and then I will have definition of my index. Okay, definition of my index, and this definition will be again a JSON with a key called fields. Now inside this fields, now you see this is getting pretty complicated, and if you don't understand these individual fields, you might get confused. Okay, so inside this fields I need to specify the field on which I want to create the index on. Okay, this can be an array with multiple fields. Here again I will have a JSON, and I can have, as I'm suggesting, I can have multiple JSON. Here in this JSON I will have in the fields, I will have first of all a type of field, and here I will have a vector field. Okay, I will have the maybe path of the field. Path means like which is the sorry, I think here I did something wrong. One second. Okay, so I have a path. Path will be embedding, and after path I will have similarity. What kind of similarity I will be okay, shit. All right, I think we got the command back, right? Okay, so after similarity, and then after similarity we will have number of dimensions. So I am specifying all the fields that are required for my vector search. Okay, and here since we only passed three entries, I can specify three here. Inside the similarity I can specify cosine similarity, and there are other similarities as well, but let's keep it simple, and let's keep cosine similarity. And in the path I will specify the embedding name. embedding name, and in the type I will specify vector. Now let's come to the outside of the fields. In the definition, we specify name of the vector search index, and we specify type. In the type, I can safely say vector search. Okay, and inside the name, I need to specify the name of my vector search index. I will maybe say products vector search index. I hope it is not getting confused, but if you try to structurally think about this command, it is very simple. So we run this command. Run command takes a JSON. JSON takes two keys. First is create indexes, and then indexes list. Also, one more thing, I think I missed this part. Create a search indexes will take the name of the collection on which I want to create search index. So here I have a collection called products, because I am running this command on a database level. Okay, so in indexes I already specified the type of index as vector search. Okay, so now if I hit enter, one second, I missed something. So okay, so I closed this fields, but I did not close the fields. Okay, now I close the fields, and fields, one second, no, I'm not sure. Okay, so this particular list has closed fields. This has closed fields array. This has closed fields JSON, and outside this this has closed indexes JSON, and then this is indexes, and after this I need to specify this and this. Okay, okay, it says Mongo server error, use command indexes, number of dimension is required, but we did provide number of dimensions. Oh, num, oh, I see. I think I misspelled the number of dimension. D should be capital. If I hit enter, you see now index is created, and we see this vector search index, and it has been created on where? It has been created on the products collection. I hope you were able to understand this command, because this is an involved command, but if you get a hang of it one or two times, you will be able to basically master it in no time. So let me clear my screen and then start with the final process of actually querying the um, index that we just created. Okay, so now to query it, I need to uh, call it on products. Okay, so products is a collection, and there is a command called aggregate. Now aggregate is going to take a you can say array. You see array, please try to keep it one second, let me I think I realized it very late that I should have increased the size of this uh, this window. Okay, so db.products.aggregate, this aggregate is going to take two, you can say, JSONs. Okay, and these two JSONs, you can say, will have one key each. So first key will be vector search. Okay, and this vector search will also be a JSON, and this second JSON that we just created will also take a key called project. Now project is just a short form for projection, like in the output what are the fields that you would like to see. Okay, now inside the vector search I can specify multiple fields. I have to specify multiple fields. So first is, what is the index I want to refer? Okay, second is, what is the path that I want to refer? Third, what is the query vector that I am dealing with? Okay, number of candidates, and I will tell you about number of candidates in a moment, and then limit. Okay, now let's fill out these. What was the index that we just created? I forgot actually what was the index name. So I remember vector search something like product. Let me maybe one second. Okay, sorry for that. Let me quickly. Yeah, so this was the my vector. So products underscore vector search index. So this was my name, products vector search index. Okay, I'm writing it down so that I don't forget now. Okay, we lost that command, so let me write it again. So db.products.aggregate, and aggregate will take a list. Okay, it will take a list, and inside this list we will have two JSONs, and inside this JSON, one second, and inside this JSON I will have a key called vector search, which is going to be a JSON, and here I will have a key called project. Project means in the output what kind of fields I want to look at. For now, let's say I only want ID. Okay, so sorry, ID 0 means I don't want ID. If I want ID in the result, I want to keep it as ID as 1. Okay, in the vector search JSON, I want to specify some keys, such as what is my index. That is what we forgot earlier, so let's write it down. So products vector search index. Okay, and after this I want to write path. It will be embedding, and then query vector, and inside the query vector let's pass some random numbers, and I'm specifying 1 2 3. In number of candidates, let's specify for now 50. I will tell you what this 50 would mean, and limit would be, let's specify as 3. And if I hit enter, let's see if it works or not. It says executor running a product cause when number of candidates is required, and we did, oh okay, again we did a typo. See, that's how you learn, right? I did a typo, and I saw the error, and if you learn this way, then you will not get intimidated by errors. See, if I had just used ChatGPT to generate the command, yes, it would have worked definitely, because nowadays these models are pretty good. Now they would have worked, but you would not have seen these internal mechanics of how to provide various fields and all. Now what would happen is, if you have a very complex system generated very complex code, then in that case if your brain is not able to understand something, then sometimes you can get things done by LLMs, but over time you will get frustrated and you will not become underconfident. You have to become confident in the code that you are writing. If I hit enter, you see I'm getting IDs. Okay, because I only specified that I want ID only. So let's now modify this to also get name. So if I hit enter, you see now I am getting name also, animal, flower and stool. Let's also now change the limit. In the limit I will say 1 only, and I will only get one result. So you get the idea about limit. Limit will basically give you that many results that you specify here. Now what is the number of candidates? So what happens is, in vector search you can have a collection with millions and billions of vectors, right? Now while searching, this number of candidates would basically tell the internal algorithm of MongoDB to basically look at these many candidates before coming at the final matches. Right now match is looking very simple, but over time when uh, your collections will become huge, in those scenarios you will have to tune this parameter called number of candidates. Okay, currently it won't matter if I set it to 100 or 2 or 3. It will not matter, because we have a very few number of um, we have very few number of you can say vector data points. But just to wrap this up, I would like to ins write down under this create vector search index once again. Okay, so what we do is, we call a command called db.run command. One second. Okay, now inside this run command what we do is, we specify a JSON. Now this JSON accepts two keys: create search indexes. This will be a collection name, and then there will be a indexes array, which will be a JSON. And inside this indexes array, you will have name, like what is the name of the index. Then you will have type, such as vector in vector search. You will have definitions. This is the most important field. And inside the definition will be a JSON. Inside the definition you will have a fields, and fields will be a array of JSON. So you can have multiple fields here. Okay, and each field need something like path, it needs type, it needs similarity, okay, and it needs number of dimensions. Okay, so this is what we just did um, in the run command. Okay, and inside the query we call a aggregating pipeline of the MongoDB, which takes a list of two documents. Okay, and inside the first document we specify vector search related parameters, which is a sorry, which is another JSON. And here we have a project. I hope it makes sense. And inside project and all these things, you can look at the documentation. But overall structure, if you want to tweak it and run it according to the way you wish, then and if you know these things, you will also be better equipped to interact with LLMs also. Okay, so I hope it makes sense. I'll close out this video now. Okay, so just to summarize, we saw how to use Atlas Local MongoDB image to basically create a vector search index locally within our system. Thank you so much for watching this video. Let me know if you have additional comments and additional suggestions for me. Thank you.